Hello everyone. Today we are going to discuss a data analytics project in Power BI, and here's a problem statement. So basically they have given the description of dataset initially. So we are first going to discuss that. Let's see. So our dataset has a person's age, his income, their income, and yeah. So they have their age, their income, person's home ownership, whether they have a mortgage or so I'm just converting to a table to have a better understanding. So we have basically the ownership status, employment length. So there are some values here like this is 123. This is not feasible. 123 employment length is not possible. People retire at the age of at max 70, or suppose if you have a personal business then you may have to go to 90, but 123 is not at all feasible. So we are going to remove it. Then there's loan intent. Uh, so basically, you have taken loan from for what purpose? So medical, education, a debt consolidation, a venture, or home improvement. So there are various other things which they have given here. Then there's loan grade. So bank may classify various loans into various grades. Like we have bonds of various countries, right? Like B plus or double B and things like that. So similarly, bank also categorizes their loans based on whether they could receive that value very easily or it may be some difficulty. So they could have like A grade could be very pristine, very nice. Loan recovery is very easy, and G is almost impossible. But still, you give those kind of loans because there's something called priority sector lending, and generally every bank has some kind of provision to give loans to different sectors. And then we have loan amount, and then we have loan interest rate, and loan status, whether they have already defaulted or not on that particular loan. They have loan percent income, that is how much percent of income is that particular loan. And then default on file, that which means whether they have historically defaulted someplace else, or well, basically in any in their lifetime anywhere they have defaulted, then it's a historical default. And then they have credit history length. So yeah, we'll look into this data set and do the analysis. So basically let's look at the first question. First question is using DAX, calculate the average loan amount and the average interest rate for each loan grade. So data analytics expressions DAX. So we are going to use these to get these metrics, right? Average and average of loan amount and average interest rate for each loan grade. So what we are going to do, we have already done some of these things. So I'll just show you the formula. So in this case, for average income, I've calculated the average income here, which is the average of credit risk data set, and then the person's income is there. So it's basically what you do in Excel, right? You just write average, and you refer to the column where you want to calculate the average. Then we have average loan default. So basically, it means that out of the total loans given, what is the average loan amount which has been defaulted. So in this case what we're doing is we are averaging over the same thing, but here we have activated a filter here which says that loan status is equals to 1. So if the loan status is equal to 1, then you calculate this average. So we have used this feature here, calculate. There is also another function where it is similar to the other functions that we have like sum and other things, but in calculate you actually command the function inside to do this, and then it does. You can also calculate like sum if and do other things. Then we have average interest rate. So we have referred to the column loan interest rate, and then we have done the average there. Then we have average loan. Uh, so basically this was the loan amount and this was for the income. So this is the average loan. The same thing we are going over the data set. This for another question. And then we have also calculated loan to income ratio. You can also use the divide function here. You can just write divide and then write loan average loan comma average income. That also will give you the same thing. But yeah, that also will also give you the same thing. Then percentage default based on amount. So here we have calculated initially the default loan status, the function that we calculated here, average loan default, and then we are dividing it with this total amount loan, and then we have also specified if this is not possible, you just give me a blank which is null. Similarly, we have done it for count. So in this case we are using the count function. Last time we were using the sum function. So basically this is for amount, total amount. Now suppose uh, 1,000 people have taken a cumulative loan of 1 lakh rupees. So in that case, the total amount, suppose 500 people have not uh, returned their loan and they have defaulted. But the total amount was suppose uh, for 1 lakh, suppose we take it 70,000. So 70,000 is the default. That means with value, it is approximately 70% of is the default rate. But since the total number of people are only 500, so if you calculate it uh, uh, just by the count, then we get 50%. So that's the difference there. That how many number of people. This one specifies how many number of people defaulted. This one specifies how much amount is defaulted. So basically that's the thing. Now we are going to look into the question. Question is average loan amount for each loan grade. So here I've used, for this visualization, I've used the matrix visual, and I've specified the loan grade to rows, and in the values we have specified average loan, average interest rate, the percentage default rate. You can directly use the loan amount here. Now suppose if I use the loan amount here and then I do the average, then also it's possible, since both of these are same, you can see, then also it's possible to get the average. But when you use DAX formulas, it's very clear and concise that okay, fine, this is what we are doing and it is being done over this particular range. So that's how we have calculated the first part. Here you can see that the loan grade, which is G, has the maximum default based on amount as well as based on count. That means approximately in both these cases, approximately all of the people who have taken the amount are defaulting. Almost like 1 or 2% of people, or 1 or 2% of the value is getting returned to the. Whereas look at the A value. A value is the percentage default rate based on amount is only just 11%. That means only 10 to 11% of people are defaulting if you have loan grade A. But look at the value of average loan. Average loan here is 17,000, which means that maybe there are less number of people here who are taking large amounts, and here we have more number of people, even if yeah, more number of people, and they are taking small amounts. So that's why the total average is this much only. But the return the default rate is 11%. So I've shown the same thing in the column chart or the bar chart. So bar chart, G is the worst since the default rate is maximum, and A is the best since the default rate is minimum. Let's look at the next question. Next question is visualization of loan status. So loan status is either 0 or 1. So 0 means you have not defaulted and 1 means you have defaulted. And they are asking to show us across various employment length and home ownership statuses, which combination shows the highest default rate. So for this question I did another thing. So uh, we have to add a conditional column here. So in this case, what you can do is the default status. For this, I have added a direct DAX based conditional column. I've used the if statement and I've used loan status is equals to 1. Then the column name is default, or else it is non-default. But for this thing, I have used actually the Power Pivot. You can go to your uh, go to transform data, and here I have added the conditional column. This is the conditional column that I've added. You can see, I'll show you the edit settings here. Yeah, so the employment length, if it's less than 2, it is 0 to 2, and so on. It goes on, and you can hence create a column here which specifies what is the employment category. Some of the values here is given to be, I think, expression error, but I think it's fine. No. So go to close and apply. So we have got the table, and we have got the column for both the things that we need. So in this case, we want to see, what we want to see is, we'll just load this. So in this case, the next question is loan status across different employment lengths. So we have categorized the employment length and home ownership statuses. The home ownership, we already know, they either own it or they rent it, or there's some other parameters. So I'll just check. Rent, mortgage, other, and own. So yeah, there are 4 categories, and we are going to see which one has the most default rate. So in this case, what I've done is, this is just a column, sorry, matrix or a table, you can say. And in rows, I have added the home ownership status, and the category I have added employment category. And in the columns, I've added default status, and the values is count of loan status, which means if I select all of these filters, we get the default number of people who are defaulted and the non-default people as well. So you can see that in the rent area, where you have 2 to 5 or 0 to 2, the total number of people are very large. Rest others, we also have a high amount of people here, but it's not as comparable to this one. This one is very high. These two brackets are very high. So from 0 to 5, if the employment group is there, the loan default is maximum. You can see from here as well. Now suppose if I just want to look at the default people, the people who have already defaulted. So once I look at this pie chart, it says the employment is category, when it is just this, yeah. When the employment category is between 2 to 5 and rent, then approximately the total amount which has been defaulted is 25.22%. And here also, this is 0 to 2, and then here also it's rent, and this combined makes 25 plus 19, 0 to 5 years, so almost 35% of the loans which have defaulted, which is a very high number, And here also I've categorized, so you can look it in the column chart. So you can see 19.4 million is the total amount which has been defaulted here on rent from 2 to 5, and for 0 to 2 also the rent is 15.2. So both of these kind of makes up for the maximum amount of loan which has been defaulted. Let's look at the next question, segmentation analysis using loan intent. So intent is the purpose for which you borrowed the money, right? So in this case, the borrowers by loan intent and visualize the average income and average loan amount for each segment. Which intent has the highest loan amount to income ratio? So basically, they want to know the income to loan ratio. We have already a measure which we have calculated loan to income ratio, right? Now we are going to use this. So let's go to intent. So this is, they want to know what is the average loan and average income by intent for each category. So you can see the highest is for home improvement, the average average income, and the loan is also 10,360 for home improvement. If I look at this one, this is a bit lower, this is also a bit lower, all of them are lower than this. So the average loan taken by home improvement people is maximum, and the average income is also maximum. Here I have shown average loan versus average income in a kind of scatter plot with details on various intents. So it's the same thing, it's just represented differently. Now let's look at the loan to income ratio. Loan to income ratio is a bit similar for all of them, but the maximum comes out to be for the medical. So the medical people, you can look here, they are taking very low amount of loans, and the income is also not that much. But since the difference between these two is very low and these two is relatively high, overall this number comes out to be greater. So for medical loan to income ratio is the maximum, which is approximately 15.07%. Let's look at the next question. Next question is time series analysis. Time series analysis analyze how the loan default has changed over years. Implement a slicer to adjust the viewed period. So here what we have done is go to credit history. So on the x-axis we have credit history. Let's look at the visual here also. Visualizations. In the x-axis we have the credit history of the person. In the y-axis we have count of loan status. So loan status is either default or non-default, and we are counting it over every credit history, which is a whole number. So for 0, if the number of years is 0, we are counting how many people have loan status as default or non-default and how many people have default. So this is a stacked area chart, and you can see it is bifurcated here. So you can see that the people here after approximately 18, there are not a lot of people here, and very less people have defaulted, like 15, 4 out of 15, which means approximately, but still it's very large amount since it is 25% of the total people who have defaulted. And here the default rate is also a bit like 1/3 or 1/4, something like that in between. So you can see the temporal trend here. With increase in credit history, the total number of default or non-default rates actually decreases. Let's look at the next question. Next question is what if parameter. So what if parameter, what you have to do is okay, we'll first read the question first. Create a what if parameter to simulate different scenarios based on varying interest rate. So we want to vary the interest rate and see how the things fluctuate. How do changes in interest rate potentially affect the default rate? So we are saying now they have specified that we want to see the changes when interest rates are changing. How are the default rate changing? The problem with this statement is there's no such formula that you can directly apply that okay, interest rate is k into default rate. But still, just for the process of presenting the visualization, we can do it. But actually calculating the default rate and interest rate takes a lot of economics and finance into hand, and you have to take a lot of human factor as well. Then only we can potentially research and make statements regarding the same. But just to show that how if suppose the relationship is linear, then we just want to see how much is the increase or decrease. Then we can do it in Power BI, and we'll show it how to do it. So in this case, what I've done is I've created a parameter interest rate scenarios. So for that, you have to go to modeling, you go to new parameter and numerical range. So basically I've defined, you define a parameter here. Suppose I want to change my parameter from 1 to 40. Now suppose my interest rate increased by 40% initially, and the increment is like initially it is at the same level as the default interest rate. But now suppose if it increased by 1%, 2%, so I'm keeping the increment here as 1, and the maximum I'm keeping it as 40, and then I have created already a slicer and I've added to the page. Now after creating the slicer, you get two measures. So the first measure, it just generates a series that we selected series from 0 to 40 with a step size of 1. So this has been generated. The second thing that have been generated is this. So interest rate scenario value is, once you write here what is the value here, it will select that value in this, and then it will specify that value. So from this series, another calculated measure selects a particular value. But now if you change it, uh, it won't affect unless and until you connect this to your visual. So for connecting this to the visual, we know that we have a parameter which is a selected value of here, interest rate scenarios value. And what I've done is I have created another calculated measure where I have, yeah, where I have just multiplied this value to the default rate based on count. Now suppose my interest rate increased by 1%, I'm assuming that the default rate also increases by 1%. So in that case, I've just used the simple interest formula, which you know that it's the same thing, 1 plus 0 point whatever the increase is, or the percentage based formula, and then you multiply it by 100 and you get the interest rate. So in this case, initially the value is default. Sorry, initially the value is default by 0. Okay, so if I suppose increase it by 5%, you see that this value remains the same, but this is my default based on interest. So once the interest rate increase by 5%, my default rate should also increase by 5%. But in general, this is not true. This is just for a visualization purpose. So basically, this is how you can create a what if parameter. Let's reset this value to 0. See, suppose if I want to increase by 40%, then it increased to 40.0. So the default rate increases to 40.02, right? So this is, but in reality what happens is, once you set a default rate, or once you set an interest rate, even a little bit change, a minute change in the interest rate could affect a lot of things. Human behavior is one of the very difficult things to predict, and it involves a lot of modeling, and this simple equation does not justify the analysis that we have done here. We need to go into more depth and details to analyze this. Now let's go to the next question. Next question is geographical data exploration. Geographical data exploration were available. How would you visualize loan distribution and default rate across various regions? So I'll just show you if the geographical data was available. I'll create a new dashboard. So here we have got maps, right? So this is the map, this is field map, and this is shape map. Shape map I generally don't use because in general it always gives shape of only US. Either there's some error or there's some problem, or uh, I don't know the intricate details how to change it properly. But for the field map, what you can do is you can if you have any location based field here, you can just drag it to location, and then you can add any value to the legend. It will just create the plot. And then here also in this map creates a bubble map. So in case of bubble map, what you do is you just drag the location or the city or column anywhere in this area, and then you can also, suppose you want to see the person's loan amount, so you drag to uh, bubble size here, and you can change the bubble size based on, but since we don't have any location here, uh, it will not take the values right now. It will not show it on the map since we need to have some sort of field value based on this. So I'll just show you if I can get uh, yeah, so this is my COVID dashboard, and I have created a small map here which is which just gives the death rate by country, and then also it gives the tooltip values. So here you can see, here you can see this is the debt by country, and you can actually go and look at this visual. Here we have our visual here. This is the field map. We have added some tooltips. In this case, what we have done, we have added country to the location. From this table we have country, and we also have continent. You can also drag continents as well, and we have added in the tooltips various values which you can see if you click on or even hover over the countries here. So this is how you can create. Now suppose if I want to convert this into a bubble chart, you can bubble map, you can just click on this one, the small circles, so it will create a bubble map here. And the shape map is it gives only for US, so that is some kind of problem here. That is why I don't prefer this one. So now let's go to the next question. We have done work content, accurate history, scenario possibility we have done. We have done for geographical area location. Now we have to do for advanced DAX risk assessment. So advanced DAX risk assessment is basically they want to calculate the risk score for each loan considering factors such as loan amount, percent income, default history, employment length, and other factors which you can include. What I thought was, now suppose if you want to think of risk, we don't have the exact formula. So if I want to construct a formula, so my risk value, I'll just show it. My risk value generally, so my risk value here is generally proportional to what you can think is the loan amount. So the loan amount is if you have given a high amount of loan, the risk is equally large. And if the percent of income, the loan is very high as compared to the income that the person is earning, then also the risk is very high. And if a person has already defaulted, then also the risk is high. So these three directly relate to high risk. And if the person is stable and employed for a long time, that means the risk is lower. And if the income amount is also very high, then the risk is also very low. So I have just assumed that risk is directly proportional to the loan amount, percent of income, and default history divided by, which means it's just inversely proportional to the employment length and the income amount. One thing that I have done here is I have created a default history and I've given it values. In the sense, if a person has already defaulted, I'm taking it as 1. And if a person is not defaulted, that means the risk is 50-50. So I'm just taking it as 0.5. So yeah, this is the basis on which we are creating the formula. Let's look at the formulas. So we have risk default. I have created this column. So if the credit risk of loan status is equal to 1, that means if he has already defaulted, the value will be 1, or else it will be 0.5. And then I've taken the whole formula here. So I've just used the function divide, and then the numerator I have those values which are directly proportional, and that means risk default rate, loan percent income, loan amount, and in the denominator we have employment length and the person's income. So I've gotten a raw calculation from this, right? So I'll just show you the table here. In this case, you can see the risk total. I've given the default risk of 0.5 to those which are the loan status of 0, and if it has defaulted already, so the loan status is 1. Risk default rate is 1. Risk total is just multiplication of all those factors, and then I've realized that this number is very small, so I just normalized it to get the number more presentable. So that is how I have calculated the risk default rate, the risk default rate. Not risk default rate, just a sec. Risk assessment. So I have to calculate risk score. So that is a risk score. So this is the normalized risk score that I have ultimately created by multiplying a constant, and I have created a normalized risk uh, based on employment category, a visual, just for a fun to see how it changes. So you can see that 0 to 2 years, the risk is very high, right? If the employment is 0 to 2 years, the risk is very high. And if it is 2 to 5 years, the risk is relatively lower than 33.34. If it is from 5 to 8, it is 4.74, and then it decreases to 2.98, and then it decreases to 1.90. So this is a waterfall chart that I've created to visualize the risk score over the employment category. Let's look at the next question. We need to implement the role level security. To implement the role level security, what you do is you go to modeling, and here you have manage roles or views. So now suppose in my data set I want to share the uh, share all the values, or share the details of the people who have defaulted to the person who is suppose a asset reconstruction company. So what they will do is they will take all the loans from me, and then uh, they will try to recover those loans. So they just want only the defaulted people details, right? So I've created a role here which is default role, and then I have from my data set I have created a conditional column. You can also use the DAX editor to create such column where the default status is equal to default. So default is a value in that particular column, and default status is the column name. So I've just created that and I've saved it. So this thing is already created. Now you publish it to the Power BI service. Now suppose if I go to Power BI service, Here I have to go to my workspace. In my workspace I have this thing which I've already added. It's a semantic model. So now here I'm going to security. In security you see this default is given, right? So I have to add any member who I want, and the file will be shared with them. So this is how we share the row level security to the people who we, who need these row level values. Now let's look at the last question, which is dashboard creation and publication. Design a comprehensive dashboard that includes all of the above analysis. Include navigational features and tooltips. How would you publish and share this dashboard with the stakeholders in the Power BI service? So I've created this dashboard. Um I could have taken all those values which I've created earlier and added it, but it wasn't very nice. So I've just created some bins which gives the average income, average loan, average default rate, average loan default, and average interest rate. I've also created a pie chart which gives the loan grade value and its percentage default rate. Here I have got employment category and average income, average interest rate in a um, combined chart basically. So this is a main dashboard. It's very simple. Now if I want to go to other pages, I have created a navigational columns. So to add that, you just have to go to insert. From here the buttons, you have the called the navigator. You add the page navigator. Once you get the page navigator here, you can edit how they look based on visual shape, rotation. And to go to any page, you just have to press control and click on that particular thing. So I can navigate to various dashboard, and this is my dashboard creation. Thank you for listening. Hope you enjoyed this. Have a good day.